Hello my dear student, I am Soham Jagad. Welcome you in science class. We are in the chapter number 9 of our science, that is force and laws of motion, that is physics chapter, and that is chapter number 2 in our physics part. In the last lecture we have seen exercise numerical, and I think we are question number 11 in our exercise. So let's see data first, and I hope you are watching this lecture with your textbook and science fair book. And if you are not with your textbook and notebook, so please quickly get your textbook and notebook and please note down all important point and solution with me. So here we have example number 11, that is two objects each of mass 1.5 kg are moving in the same straight line but in opposite direction. We have two objects with mass 1.5 kg are moving in same straight line but in opposite direction, which means they both are moving along each other. The velocity of each object is 2.5 meter per second before the collision, during which they stick together. After collision. What will be the velocity of combined object after collision? So let's understand data first. We have two objects. Question number 11. We have two objects. Let's say this is object M1. This is object M2. Both has mass 1.5 kg. So I have to write here M1 is equal to 1.5 kg, M2 is equal to 1.5 kg. Both move with the same velocity, that is initial velocity. U1 is equal to 2.5 meter per second, and here is the important point. If I consider this ball is moving in this direction, it is in right direction. If I consider right direction as positive, so I must take this left side direction negative. So here I have U1 is equal to minus 2.5 meter per second. So here I have U1 as minus 2.5 meter per second. So we have to find combined velocity after collision. Let me write given data here. We have two objects, that is with mass M1 as 1.5 kg, mass M2 as 1.5 kg. Initial velocity U1 is equal to positive 2.5 meter per second and U2 is equal to negative 2.5 meter per second. Why negative? Because both balls or both objects are moving in opposite direction. This object is moving in this direction, this is moving in this direction. If I consider this as positive, so I have to consider this as negative. Or in either way, if I took this as positive, I should take this one as negative. So remember the point, if objects are moving along each other, we have to take one as positive and one as negative. So here we have velocity positive, here negative. Now after collision they combine each other, means after collision they will be something like this, m1, m2. Now we have to find the direction and velocity of these combined objects. So what we will do, we will apply law of conservation of momentum, that is total momentum before is equal to total momentum after. Before and after what? Before and after collision. So we have total momentum before is equal to total momentum after. So total momentum before is equal to m1 u1 plus m2 u2. So we have 1.5 m1, u1 is 2.5 plus m2 is also 1.5 multiply u2 is minus 2.5. Here you can observe this is 1.5 into 2.5, this is also 1.5 into 2.5, which means this both value is same. Value is same but sign is opposite, that is this is plus and this is minus. So positive, negative, it will be cancelled out and we will have answer as 0 kg meter per second as momentum before. I hope you got the point. Now we have to find momentum after collision. So I write total momentum after collision is equal to m1v plus m2v. Why I write only v and not v1 and v2? Because after collision these both objects stick together and move. So I write v as both velocity of object. So we have v as common, m1 plus m2. So I have v that we have to find m1 plus m2, that is 1.5 plus 1.5, 1.5 plus 1.5. So we have total momentum before is equal to v 1.5 plus 1.5, that is 3. So we have 3v kg meter per second as momentum after collision. So by law of conservation of momentum, this result number 1 will be equal to result number 2. Why? Because total momentum before is equal to total momentum after. So I compare both result 1 and 2. So I have 3v is equal to 0. So I have v is equal to 0 by 3. So I have v is equal to 0 meter per second. What does it mean? It means that after collision they stick together and its velocity will be 0, which means it is in this situation. They come together and goes nowhere. This is the situation. So velocity after collision will be 0 meter per second. So I hope you got this example and understood the situation clearly. Now we have example number 12. So read the data from your textbook. Question number 12 we have on page number 129. Read the data. According to the third law of motion, When we push on the object pushes back on us with equal and opposite force. That we know. By third law, if we push the object will push to us with same magnitude but in opposite direction. What is the question we have? We have, if the object is a massive truck parked along the roadside, it will probably not move. Obvious. If I push the truck that is parked along the roadside, will it move by my muscular force? Of course it will not. So what's the question? A student justifies this by answering that the two opposite and equal forces cancels each other. Comment on this logic and explain why truck does not move. So one student make a sentence on this, that two opposite and equal force cancel each other. Is it true or not? And also we have to tell that why truck does not move. So let me explain you. What should I do to move this truck? Suppose this is the surface and the truck is like this. Truck will be like this on surface. Here truck is in contact with road. Here truck is in contact with road. If I want to move this truck, with my muscular force, what should I do? I have to overcome this frictional force. As we know that truck is very large and with lot of mass. So here we have very large frictional force that cannot be overcome by our muscular force. Obviously we apply some force on truck, and at same time truck will also apply same amount of force but in opposite direction, which does not mean that this force cancel each other. Actually they do not cancel each other. Actually the force which we are applying is somewhat lower, that is not sufficient to overcome this friction. If somehow I apply greater force that is sufficient to overcome this friction, I can move this truck. So I hope now you understood what should we do to move this truck and why this force does not cancel each other. They are not cancelling each other. They are still acting on one and another object. This force which is applied by us is on truck, and this force that is applied by truck is on us. Okay, so that is the answer of this question. Now let's move on to question number 13. Read the data. Question number 13, that is on page number 129 of your textbook. A hockey ball of mass 200 gram traveling at 10 meter per second is struck by hockey stick so as to return it along its original path with velocity 5 meter per second. Calculate the magnitude of change in momentum occur in motion of hockey by the force applied by hockey stick. We have to find change in momentum. So let's derive data first. Question number 13. We have one hockey ball like this, which is moving in like, suppose, right side direction with velocity u1. Velocity u1, or say only u, because we have only one object here. It is struck by hockey stick. Let's say this is hockey stick and it is struck by hockey stick and move it on its original path, and then it will move in its original path with velocity, say, v. So here we have u is equal to, first of all we have mass is equal to 200 gram, and now tell me, this 200 gram is in SI unit? No, this is not in SI unit. So what we have to do? We have to convert it in SI unit. So I have to convert this into SI unit. So I have to divide it with 1000. I hope you know 1 kg is equal to 1000 gram. So I have to divide this 200 with 1000. So I will get 0.2 kg as mass of this ball. Initial velocity u, that is 10 meter per second. That is 10 meter per second. 10 meter per second. Now my dear friends, important point. If I took a right side direction as positive, I have to take left side direction as negative. So I have to take final velocity v as negative, and this value of negative is 5 meter per second. We have negative 5 meter per second. What is negative? This negative sign is nothing but direction of velocity. So direction is opposite to direction of initial velocity. So here we have minus 5 meter per second. We have to find change in momentum. So change in momentum. You know this symbol delta P? Remember this symbol delta P? I told you in previous lecture, delta is change in any quantity. So this delta P is change in momentum. What is change in momentum? That is final minus initial. What is change? Change is final minus initial. So first of all, I have to find final momentum and initial momentum. So, and we know that P is equal to mass into velocity. Okay. So initial momentum is equal to mass into initial velocity. So mass is 0.2 kg and initial velocity is 10 meter per second. So I have 0.2 into 10, that is 2 kg meter per second as my initial velocity. Okay. Now final velocity PF, that is mass into final velocity. So I have mass 0.2 kg and final velocity as minus 5 meter per second. So here I have 5 2s are 10 and this 0.2 means 2 divide 10. So this 10 will be cut. So I have 1 kg meter per second. But here we have 0.2 into minus 5. So don't forget to put this negative sign. So we have PF is equal to minus 1 kg meter per second. Now what is change in momentum? That is delta P. So I will put value here. Delta P is equal to PF minus PI. What is PF? That is minus 1 minus what is PI? That is 2. So I have delta P equal to minus 1 minus 2. That is minus 3 kg meter per second. So I have 3 kg meter per second as change in momentum of this ball. Question number 14. A bullet of mass 10 gram traveling horizontally with velocity 150 meter per second square strikes a stationary wooden block and comes to rest in 0.03 second. Calculate the distance of penetration of bullet into the block. Also calculate magnitude of force exerted by wooden block on bullet. Okay, let's understand data first. We have one wooden block like this, and there is one bullet fired on this wooden block. This bullet traveled with velocity 150 meter per second, and it will hit this block, and obviously it will penetrate into it. So we have to find this distance of penetration, that we called as S, and to travel this distance, which means from starting of block to this penetrated distance, it will take time of 0.03 second. And we have to find force exerted by block on bullet and acceleration of bullet. Now I hope you understood this situation, so I will remove it because we have little bit longer question here. Derive data, question number 14. Question number 14. Mass is 10 gram. Mass is equal to 10 gram. Quickly convert it to kilogram. 10 divide 1000. So I have 0.01 kg. That is in SI unit. Mass. With velocity 150 meter per second. Final velocity. After stuck into wooden block, bullet will stop. So final velocity V. Let's say distance of penetration is equal to S. Okay. Force exerted by wooden block on bullet. Force exerted by wooden block on bullet. That is question. Now we have value of M, U and V, and we have to find S. Here we have value of V, U and M. Try to remember equations of motion. We have 3 equations, and from that equation I want to find distance. So I have one formula. S is equal to ut plus half at square. So for finding S, I need U. Yes, we have U. T. Yes, we have T. What is T? We have given here. T is equal to 0.03 second. T is given in our data. So we have T, but we don't have A. We need A, acceleration. So let's find acceleration. What is acceleration? by definition I can make formula for acceleration. Acceleration is rate of change of velocity. So I have v minus u divide t. V is 0 meter per second minus u is 150 meter per second divide t is 0.03. So I have minus 150 divide 3 by 100. So I have minus 50 numerator. So I have 50 into 100, that is 5000. Acceleration is in meter per second square. So here I have value of acceleration as minus 5000 meter per second square. Why minus 5000? Because velocity is decreasing. Okay, velocity is 150, that becomes 0. So I told you in previous lectures many times that when velocity will be decreased, this acceleration will be negative. So I have value of a now. So I have to put value of u, t and a here. U 150, t set, that is 0.03 plus half, a, that is minus 5000, and t square, that is 0.03 square. So here I have 150 into 3 divide 100 plus into minus, I will put here minus, half into 5000 into 3 by 100 into 3 by 100. Okay, this 0 will be cut. 5 3s are 5 2s are. So I have 3 into 3, that is 9, divide 2, that is 4.5. 3 3s are 9, divide 4, 2.25. So distance penetrate in wooden block will be 4.5 minus 2.25. 0.50 minus 0.25, that is 0.25. 4 minus 2, that is 2. So I have distance 2.25 what? Meter. 2.25 meter distance penetrate into wooden block. Can you imagine this distance? What is 2.25 meter distance? Suppose this is 1 foot, this is 1 foot, and 1 meter is nearly equal to 3 feet, that is 1, 2 and 3 feet. Here is 3 feet. Approximately 1 meter. This is 1 meter. This is 2 meter. And approximately this much distance will penetrate into wooden block by this bullet. You can imagine how fast this bullet came into this wooden block, that is 150 meter per second, and only fraction of time, that is 0.03 second time, it will penetrate into wooden block. I hope you can imagine the situation. Okay, so we have distance penetrate, that is 2.25 meter. Now next we have to find force. Force is nothing but, remember third law of motion, force exerted by bullet on wooden block and force exerted by wooden block on bullet will be same but opposite in direction. So I will take F is equal to ma, that is force exerted by bullet on wooden block. Okay, so mass of bullet is 0.01 multiply acceleration is minus 5000. So I have 1 divide 100 into 5000. So I have 50 Newton minus 50 Newton as force exerted by bullet on wooden block. So same magnitude but in opposite direction. So what will be our answer? Our answer will be 50 Newton. 50 Newton, that is same magnitude but in opposite direction. So we have answer as 50 Newton as force exerted by bullet on block. So I hope you got all this point, and please practice this numericals by yourself. Then and only then you can command on this numericals. Thank you.